Hello geometry class, and welcome to this video, which is an extension of section 12.3, where we're going to take a look at the surface area of the conical frustum. So the conical frustum is this shape down here. It looks like a lampshade, or maybe where one of those old-time lion tamers would stand, and they'd have a chair. That's a terrible chair, but they have to keep the lion tame because the lion is probably angry. That's terrible. Okay. Used to be pretty good at Pictionary, but I haven't played in a while. So anyway, so that's what a frustum is. I guess the real better way to describe it is it looks like a cone that's been decapitated. And the way we're going to find the surface area is by actually treating it as a cone that has been decapitated. So just to identify a couple of parts of the frustum, we have two different radii here for our two circular bases. We have a smaller circular base and a larger circular base. The frustums that we're going to look at, those bases are parallel to each other, but the circles are not congruent, otherwise it would be a cylinder. So, so we have the two different radii, and they're separated by a height, and then that of course is different from this slanted height right here, which we'll call L. All right, so in our frustum we have an upper radius of 12, a lower radius of 18, and a height between them of 8. Okay, so as I said, we are going to treat this as a decapitated cone. So what I will actually do is draw in the cone as it used to look, like that. And we're going to find the surface area of the frustum this way. The surface area of the frustum is going to be equal to the surface area of the large cone. So the entire thing, but we have to subtract away parts that are not there anymore. So what are we going to subtract away? We're going to subtract away the part of the decapitated cone, of course, but not the surface area of that cone, just the lateral area of that cone. So the lateral area of the smaller one. And then we have to add back this smaller base up top. So we're going to say plus the base of the smaller cone. Okay, so if I take the surface area of the entire large cone, I do get the base on the bottom here. And then I'm going to subtract away the lateral area of the small cone. And then I'm going to add back the base of the small cone. And that will give me the surface area of the frustum. Now, when I do that, I'm missing some measurements. And so I'm going to need some similar triangles in order to find out what these missing measurements are. Okay, so let's start with our large cone. Okay, I just wanted to get rid of some of the mess there. Now, this is 8, this is 12, this is 18. The first thing I'm going to find is that slanted height of the frustum. And if I draw in this height there, that's also 8. You can see I make a right triangle. So the distance from the center to there is 12. That's the same as the radius up top, which means that distance is 6. And look, I have a 6, 8, 10 right triangle. So 10 is the slant height of the frustum. Now, luckily for us, we have similar triangles there. So I'm going to use proportions to figure out what the slant height of the smaller cone is, and then add that to 10, and that's the slant height of the larger cone. Okay. Now, the two measurements that we know we have are the two radii. So 12 is to 18. So 12 is to 18 as, let's go for the slant heights, as this slant height here, which I'll call x, is to the slant height of the large cone, which is x plus 10. All right. Now, if I try to solve for x, let's go ahead and do that. So I'm getting it. 18x is equal to 12x plus 120. So that means that 6x is 120. So x is 20. So 20 is the slant height of the smaller cone, which means that the slant height of the larger cone is 30. Okay, now I believe I'm ready to find the surface area of the large cone. So the surface area of the big cone is equal to pi times my radius, which is 18, times the radius plus the slant height, r plus L. And then I'm going to get, let's see, 18 plus 30 is 48. And I'm just pulling on my calculator. So 48 times 18, I get 864. So 864 pi. That is the surface area of the big cone. Okay, now let's go for the lateral area of the small cone. And so I think we have everything we need for that too. The lateral area of the small cone is pi times the radius times the slant height, and the radius of the small cone is 12, and the slant height of the small cone is 20. So we can just do pi times 12 times 20, which is 240 pi. And the last thing that we need to find is the base of the small cone, which is just pi r squared. And we know the radius is 12, so it's 144 pi. Okay. Now I can plug everything in, and so my surface area of the frustum is going to be the surface area of the big cone, 864 pi, minus the lateral area of the small cone, 240 pi, plus the base, the top base, the base of the small cone, plus 144 pi. Okay, and so we do 864 minus 240 plus 144, and we get 768 pi. And that is the surface area of the frustum. Okay, so just to recap, we draw in the decapitated head. We use similar triangles and proportions to find the measurements of that small cone. And we use this idea that the surface area of the frustum is the surface area of the big cone minus the lateral area of the small cone plus the base of the small cone. And that's how we get the surface area of the frustum.